Hi dear students of +2 medical and non-medical respected teachers. Today I am going to discuss electrical conductivity of a semiconductor from the chapter of semiconductors for +2 class. So let us start. So we have to derive expression for electrical conductivity of extrinsic semiconductor first. Extrinsic semiconductors are doped semiconductors which are N-type and P-type. Suppose we have any extrinsic semiconductor having length L, area of cross section A. Suppose N is equal to number density of free electrons, NH is equal to number density of holes, and the sample is connected to a cell so that current starts flowing through the semiconductor. And these electrons are attracted towards positive end and holes towards negative end. As a result, flow of electrons and holes starts, and hence current starts flowing in the circuit. Then let V is equal to potential difference across the ends of the semiconductor. Then electric field due to this potential difference across the ends of the semiconductor is given by E is equal to V upon L. So because electric field is equal to potential difference per unit length. Therefore total current I through the semiconductor is given by I is equal to IE plus IH, because in case of extrinsic semiconductor or a semiconductor simply, current is both due to electrons as well as holes. So total current is equal to sum of the current due to electrons and current due to holes. Then I is equal to NeAV, Ne number density of electrons into E charge upon electron into A area of cross section into VE plus NH E A VH, because relation between drift velocity and current is equal to I is equal to NEA VD. So here current is due to both electrons and holes. We have two terms. This term is due to electrons, this is term due to holes. So VE drift velocity of electrons and VH is the drift velocity of holes. Therefore I is equal to E into A can be taken as common, Ne VE plus NH VH. Now dividing by A throughout, I upon A is equal to E Ne VE plus NH VH. But I upon A is called current density, current per unit area. So J is equal to E Ne VE is plus NH VH. Now by Ohm's law, current density is given by J is equal to sigma E, where sigma is the electrical conductivity of semiconductor, E is electric field, J is the current density. So therefore, comparing these two equations, so we had sigma E is equal to E Ne VE plus NH VH, or sigma is equal to divided by E throughout, so E Ne VE upon E plus NH VE upon E, because drift velocity per unit electric field is called mobility. So therefore VE upon E is equal to mu E, that is mobility of electrons, and VH upon E is equal to mu H is equal to mobility of holes. So therefore sigma comes out to be, sigma is equal to E Ne mu E plus NH mu H, which is the required expression for electrical conductivity of a semiconductor. So where Ne, NH we know number density of electrons and holes respectively, mu E and mu H is the mobility of electron and holes respectively. So required expression for electrical conductivity of a semiconductor. So from this equation we can see, when temperature increases, what will increase? When temperature increases, Ne, NH will also increase. Mobility will also increase little. So therefore, we can say that sigma, that is electrical conductivity, increases with the increase of temperature. Electrical conductivity of semiconductor increases with the increase of temperature. Now, special cases for especially n-type semiconductor, which has large number of free electrons due to donor impurity. Ne is greater than Nh. Therefore, Nh can be neglected as compared to Ne. Therefore, Ne is equal to Nd, where Nd is equal to number density of donor atoms. Therefore, sigma n, that is electrical conductivity for n-type semiconductor, is equal to E Nd mu E, neglecting mu H. For p-type semiconductor, Nh is greater than Ne. That is number density of electrons is negligible in case of p-type semiconductors due to acceptor impurity, or Nh is equal to Na, is equal to number density of acceptor atoms, which are impurity atoms added to the p-type semiconductor. Therefore, sigma p is equal to E Na mu H. So, expression for electrical conductivity of p-type semiconductor. Second case for intrinsic semiconductor. For intrinsic semiconductors, there are electron hole pairs, that is Ne is equal to Nh is equal to Ni, say number density of intrinsic carriers, that is electrons or holes. So therefore, sigma is equal to 1 by rho, because electrical conductivity is reciprocal of resistivity. So is equal to E Ni mu E plus mu H, which is required expression for electrical conductivity of intrinsic semiconductor. So this proves that electrical conductivity of semiconductor increases with the increase of temperature. So this is all about electrical conductivity of semiconductor, whether it is extrinsic semiconductor or intrinsic semiconductor, N-type or P-type semiconductors. So till next video, stay tuned. Ask your friends to subscribe my channel to stay tuned for next coming videos of all the important topics of Jigsaw 9th to 12th class. So all the best, be happy, good luck.